Algebra 2 students, and welcome to the next chapter. We're going to be taking a look at some trigonometry stuff this chapter and dealing with some of that, similar to what we did last year in geometry, or possibly 2 years ago. If you take a look at what we have here today, so I'm going to get this packet is your lesson, and I took this straight from the CPM worksheet that you used last year, possibly. Just a reminder about some of the right triangle trig. Remember that the sine of some angle, remember this is theta, is the ratio of the opposite leg over the hypotenuse. The cosine ratio is the adjacent leg over the hypotenuse, and the tangent ratio is the opposite leg to the adjacent leg. Okay? So one thing to keep in mind is whichever one of these two acute angles you're using, in this case we're calling this one theta, remember, that's how you determine which leg is opposite and which leg is adjacent. The hypotenuse is always directly across from the 90-degree angle. Okay, so just a reminder on that. If you take a look at example 1, they ask you to use the sine ratio to find the length, and they won't always tell you to use the sine ratio. A lot of times you'll have to figure that out. So if that was the case, here's the reasoning right here. The reason this is a sine problem is if this is the theta, if that's the angle I'm going to use, x is opposite that angle measure, and 18 is the hypotenuse of the triangle. And sine is the one that deals with both opposite and hypotenuse. That's the ratio that works with both of those parts. Same idea over here. 42-degree angle, x is opposite that 42-degree angle, 16 is the hypotenuse of the triangle. And so if you take a look, here's the setup for the first one. The sine of the angle we use, sine of 78, equal to opposite over hypotenuse. And then the rest of it, once you get your equation set up, then you're just solving for x. If you want, you could put this over 1 and think of this as a proportion, cross multiply. Or you could just multiply both sides by 18 right away to get rid of the fraction, and there's your answer. Okay? Same idea on the second one, just a little bit different numbers. When you take a look at example 2, again, they told you to use the cosine ratio, but just in case you didn't recognize it, you're going to need to be able to recognize it. Here's our angle measure. There's our theta. X is adjacent, is the adjacent leg to the 25. This would be the opposite leg compared to that 25-degree angle. So this is adjacent. 4 is across from the 90-degree angle, so that's your hypotenuse, and that's why it's a cosine problem, because the two parts that you're dealing with are adjacent and hypotenuse, which is cosine. Same exact reasoning over here. Okay? If you take a look at the work that they gave you, cosine of 25 for this first problem, cosine of our angle, equal to the adjacent leg over the hypotenuse. And then again, go ahead and solve for x from there. Okay? Multiply both sides by 4 and you're there. Same idea here. Only thing I want to point out on the second example is notice that x is in the denominator. So we actually had to do 2 steps. Multiply both sides by x. But x is not by itself at that point, so then we have to divide by the cosine of 62 in order to get our final answer. Okay? So just be aware of that. So the first thing is just setting up the equation and figuring out which one to use. And that will always come based on which parts you're using in the problem. Okay? If you take a look at example number 3, what I would suggest, or what you're looking at here now, is you're looking for angle measures. And if you remember back to geometry, anytime you solve for an angle measure, you're going to use inverse trigonometry right here. Okay? You're using inverse trigonometry. So what you're using is that sine to the -1, cosine to the -1, that idea. Okay? So if we take a look at our first problem here, if this is the angle I'm looking for, 5 is opposite that angle, 13 is the hypotenuse, which is why right over here, that's why we set up a sine problem. Okay? Now, the one thing that I would suggest you do differently than what they did here is instead of typing in 5/13 and getting a decimal, I would say in order to solve for theta, to get it by itself, just take the inverse sine of both sides right away. And that way you don't even have to worry about this decimal answer here. This would be the way that I would do it right here. Take the inverse sine then of 5/13. and your answer should be approximately 22.62 for that one. Okay? If we come back to part B, if this is theta, we're trying to figure out, is this a sine, cosine, or tangent problem? Well, the 8 is the adjacent leg to theta. 12 is the hypotenuse, and therefore, since I'm dealing with adjacent and hypotenuse, that would be a cosine problem. Okay? If you take a look at part D here, for example, the part below it, here's theta. There's your opposite leg is 42. Your adjacent leg is the 30. And therefore, opposite and adjacent, this is going to be a tangent problem. And an inverse tangent problem because we're looking for theta. And you can kind of take a look through. They set up every one of these problems. Here's the setup to our cosine problem. Take the inverse cosine, and that'll give you the actual answer. Okay? And so on and so forth. The only thing left then is sometimes there's examples where you have to go through. Trigonometry is one of those things that you use a lot in real life in physics, and there's a lot of with architecture and just building and things along those lines. It's used quite often. And so as you take a look at this example, this is just an application of that, okay, that you have to be aware of, and how to label different things. So I would, rather than me go through this whole thing, I'm just going to tell you, go ahead and read through this problem. They give you some good pictures here. They go through and they talk about, again, setting the problem up and finding what you need, okay? Once you've gone through all that stuff and that kind of makes some sense, the assignment's a little bit long today, but it's still not too bad. What I want you to do is, here's the problems at the end. I want you to do problems 1 through 33, I think it was. Yeah, 1 through 33 odd. Okay, just the odd problems through 33. So you've got about 16 or 17 problems to do. Okay, but this is some good practice, so it'll go back and help you out quite a bit going forward. The one nice thing about this practice guide, again, it does have all the answers right here. So make sure you're checking your work, make sure you're showing your work, so that you can then check your answers to see if you're doing things correctly. Okay? As always, if there's anything in here that doesn't make sense or you're struggling with anything, please reach out to me and communicate. Send me an email and let me know that you're struggling, or meet up with me in the chat room and we can figure it out. We'll get things figured out. Okay? Have a good day, everybody.